I'll just open yesterday's assignment as well. All right. So what we learned yesterday was we learned NACLs, NACLs, okay, security groups and NACLs, right? So what we did was, what is the difference between security group and NACL? Excuse me. So there's a very detailed, comparison of what security groups do and what NACLs do. Security groups are instance level firewall, whereas NACLs are subnet level firewall, right? So that's the difference between both security groups and NACLs. And when you apply, again, I gave an analogy of gated community where you have 200 villas and there's a exterior gate at the perimeter of this entire 100-acre property. That is NACL. Individual fencing around each villa is security group, right? And again, security group and NACL, security group is stateful, where any inbound connection that you whitelist is also remembered for outbound. Whereas NACL, any inbound is not remembered in outbound because inbound and outbound are two different transactions for NACLs. Okay, and we also did some exercises around, allowing ping or SSH from NACL and security group. And then we did a few scenarios, around 5 to 6 scenarios. Did you all complete these scenarios? Were you all able to get the desired results when you did these scenarios? Raise your hands, please, whoever was able to do it. A47 has raised, A33, A54, Z032, Z011, A02, Z045, Z054. Come on, guys. It's supposed to be an energetic morning. Let's all be bubbly and energetic. I can see only like probably a handful. 10 people have raised their hands. 10 people have raised their hands. Okay, so rest of you, I'm not sure what to assume, whether you guys did it or you're not able to do it, or you faced any challenges, or it's just that, it's a Friday is approaching and you're all not feeling so energetic to raise your hands. Okay, all right. Let's do one thing. Let's go back. Okay, so this is what we learned yesterday. It's very important you understand, what is the difference between security groups, what is NACLs, because these are all interview questions. And, I'm sure, when you attend interviews, these are the basic questions which are going to be asked, which the interviews are going to ask you. And I'm sure, you can impress them by just giving them a very good explanation and giving them real practical examples based on the assignments that you have done. Okay, cool. Let's get back to today's topic, to today's agenda. Today, I want to cover two key topics in VPCs. One is called NAT. Okay, natting, right? How many of you know what a natting means? NAT. Can somebody unmute and talk about NAT?
Network address
What is
translation.
network address translation? Okay, what does it mean?
It remaps our IP address.
Okay, it remaps our IP addresses. Excellent, very good. A24, thank you so much. Okay, so I'll just give you a few whiteboarding around natting, and then we can. Network address translation. Okay. Okay, so we're going to see that today, and we're also going to look at VPC's DNS. Okay, DNS is domain name server or domain name services. Okay, we'll see first NAT. Okay, as A24 just said, I mean, network address translation is address. What is address? IP address, right? Address means IP address. Network address translation means that it basically transforms the IP address. It's a device which sits in the middle, and then it translates the IP addresses from one zone to another zone, right? I mean, what those zones are, I'll explain you shortly. Right, so you have this is your AWS VPC zone. Okay, so this is your AWS VPC. Okay, we put a cloud symbol here because it's internet. Okay, this is just internet symbol. Okay, internet. Okay, so now, okay, let's even keep this aside. For now, I'll not even consider it as AWS VPC. I'll consider it as your home network. So you have a home network, correct? You have a router which is connected to some sort of line which is provided by Airtel or Act Fiber or Geo or whoever it is, right? Some broadband. Okay. So now that's your home network. So home network has got this is your router on the home network. Okay, this is your router, and then it's connected to the internet. In fact, it's the other way around. I mean, it's a two-way arrow, right? It's a two-way arrow, and okay, so it's connected to the internet, and you have your home network, right? And so when within your home network, you have got some devices, right? So this is your laptop or desktop, which has an IP address of 192.168.1.25. Your router has an IP address of 192.168.1.1. That's your gateway, correct? This is your gateway. Okay, and your router will have basically two interfaces, right? So one interface will be internet facing, the other interface will be private network facing. This, let me color this differently. I'll color this as, say, green color. Sorry, it was already green. I'll make this color. This is your home network. Okay, this is internet. Okay, so now this is your private network, right? Home network is private. I mean, it is basically only for you, right? So this range of IP address that you see, 192.168 is only for you, right? I mean, you don't expose this private IP addresses to the outside world. It's only an internal facing private IP address. So now you have your router. Your router will have, like, say, as I said, it will have two IP addresses, right? So it will have a private IP address, which is this. So this will be the private IP address of the router, and also it will have a public IP address. So that will be which is provided by the internet service provider, right? Some 45, 78, 87, 56, and 75. This is probably, I'm just taking some random thing, okay? Okay. So now what happens is when any request that goes outside, okay, so these two are also like back to back, right? So this is interface 1 for your router. This is interface 2. What is an interface? Interface is just an interface through which the data can pass through, right? So now if you see, your router will have, I mean, if you have a Wi-Fi router, or if you have connected your desktop to the router using the Cat6 network cable, you will have a RJ45, that blue color cable that you will have, right? Cat6 cable. So you will connect that. So that cable will have, an IP address of 192.168.1.1, or your wireless network, right? So that wireless network, if you are plugged into the wireless network, then your router will have a wireless IP address of your WLAN interface, right? That's called the wireless LAN interface, right? The WLAN interface will have 192.168.1.1, whereas the interface which is connected to the internet, where the wire from the cable from the internet service provider is terminated, correct? Which is probably a phone line, or a fiber optic cable which is coming to your home. That would be connected to the other side of the router. That will have an IP address of 45.87.56.75. Okay. So now what happens is, when my laptop is actually connecting to the internet, how does the traffic flow, right? The traffic would flow like this. First, the traffic would flow from your laptop to the 192.168.1.1, which is your gateway's IP address, private IP address, right? Because your laptop is also on the same range, right? 192.168.1.25. That's why if you do a IP config/all, you will see the gateway server as your 192.168.1.1, or whatever range that you have. In my case, I have 192.168.29 series. Okay, it's not one series, it's 29 series, but that's okay. Each device manufacturer or each router handles it differently. Okay, I'll just show you IP config/all. Okay, if config, so if you see, where did that go? Yeah, so if you see here, EN0 is my wireless interface. Okay, so if you see this, so this has got 192.168.29.6. that is my local private IP addresses, private IP address, right? And okay, it shows up better in a Windows box. Okay, but you'll also see a gateway there. Okay, I'll just show you that. So if you go to your Windows box, okay, if I just do a command prompt, I'll say IP config/all. You can also do that parallelly. So when I do IP config/all, what you see here is, you see the IP address of that local machine, which is this one, and it also shows default gateway, correct? So the default gateway is the router's IP address. It's always the router's IP address. Okay, you go to any network, okay, not just AWS or not just your home network. You go to any network, okay, you will always have a default gateway. That is always the address of that router device. Okay, that router device can be anything. That router device can be a building wise router, or whatever. I mean, floor wise or whatever it is, right? But that's a router's IP address. Okay. So now things have changed a lot these days. I mean, this software defined networking, which is actually changing the way the whole networking is being looked at. But anyways, going back to our discussions. So if I go back, I've got my laptop's IP address as 192.168.1.25. My router's IP address is 192.168.1.1, whereas the public IP, because it needs an internet address, correct? I was talking about the 450 crores IP addresses of IPv4. How much it is? 450 crores, right? Public IP IPv4 address. Yeah, 430 crores, right? 429 crores of public IPv4 addresses are there, correct? So now if you do, what is my IP? 49.37.153. This is one of this 4.430 crore IP address. Okay. So now what actually happens is when my internet connection is going through, what actually happens is my laptop connects to the private end of my router. Okay, because it's on the same network. So now what will happen is how it will connect. It will connect like this. It has a default gateway as 10.0.192.168.1.1, right? So in this case, it's 192.168.1.1. It has the default gateway as this. It connects to that first, okay, because that's the default gateway, and then it goes to the router. And within the router, you will have rules like how we had rules in our route table, correct? In our VPC's route table, we had rules, correct? Where any traffic originating for 10.0.0.0/16 has to be routed within the VPC. Anything which is other than that, which is 0.0.0, go to internet, correct? So similarly, there are going to be routings that are there in the router. We also have a router, no? VPC also. Router is nothing but the route table is the router, correct? That is the interface that you're getting. So then it goes there. So then it basically evaluates the rules, and then it says that if it is 0.0.0.0, which is not a known IP address, like I'm like browsing google.com or I'm doing something else, right? So then what it does is it simply takes the traffic to your public interface, and your public interface this is your private interface, right? Let me just put that also so that it is clear. This is my private interface. This is my private interface, and this is my public interface. Okay, this is my public interface. So now what happens is it actually goes here. I'll change the color of that. Yeah. Okay, it goes from here, it goes to my private interface. Then from private interface, my router forwards the traffic to the public interface, like how we do it in our route table, right? So where if it is for anything 0.0.0.0, you send it to IGW, right? IGW is our public interface in VPC, right? Whereas in your home router, you will have the public interface where you have the phone line connected, correct? Or the fiber optic cable connected. So that is your public interface. So then it goes there, and then finally it will reach internet. On the internet, like let's assume there is a website which is running, okay, which is called mywebsite.com. Okay, something. Okay, some website is running, and you're actually trying to access that website, right? So then what happens is, how the traffic goes is, it will try to understand the address of that, the public address of that mywebsite.com. Similarly, my website also will be in some private network like this, which will have a private IP, and it will also have a public IP. Okay, so then it goes there. It talks to the my website. Okay, it gets established with my website, and then finally, when the traffic goes from all of this, and finally when it reaches my website, the source IP address will be this, not this. The source IP address will always be your public interface's IP address, not your private interface's IP address. Okay, it's going to be your public interface's IP address, which is 45, 85, 87, 45, 87, 56, and 75. Okay, that is how it'll go. Okay, finally, when they log, within the website, if they're logging the so within the website, if they're logging the IP address, that's how it'll go. It'll go as 45, 87, 56, 75. Okay, so now that is that. So now what's actually happening here is, there is a translation that is happening between your private and public interface, where the IP address of your 192.168.1.1 is or 192.168.1.25 is getting translated as 45, 87, 56, 75, and then it is going here. Okay, finally, when it reaches the my website, and within the website, if they're logging within the website as to who all visited the website, from which all IP addresses, the website got the hits, then they'll be able to see the public IP address. Okay, so that's how it actually happens. Okay, because the private IP address will never go out. Only the public IP address that belongs to the public interface goes out over the internet. So that's how you'll be uniquely identified. Okay, so now you may ask, I have this laptop, I have one more desktop, which is 1.30. So now there are two people who are trying to access the same website. So how will it go? It'll be the same. Nothing changes there. This guy will still try to talk here. Okay, because when he does IP config, he will also have the default gateway as 192.168.1.1. He will go through this, and he will also go through the same interface. And what you will see in mywebsite.com is, mywebsite.com will still see the same IP address. It will not see the private IP address. Okay, that is called network address translation. So this is where the network address translation is actually happening. This is where NAT is happening. Okay, so please observe this very clearly, because this is what is exactly happening in our case also, right? This is what is happening in our case, where when we get a public IP address for our EC2 instance, so that public IP address is nothing but, it's a public interface which is given by my VPC to my IP to my EC2 instance, right? I mean, again, VPC is not a very small network, right? AWS is not a small network. You can't compare your home network or a home router setting to VPC, right? Because VPC is a very sophisticated and quite robust architecture, and which gives state-of-the-art networking for your servers and for your storage. Okay, so from that perspective, what in VPC you get an ability to associate the public IP addresses directly to the to one of your servers, EC2 instances, right? So that is done. But eventually, if you see, this is what happens, right? So where there is a natting that happens, and your private IP gets converted into a public IP. If you have a internet gateway attached to it, okay, and a route uh, pointing from your subnet to the internet gateway on 0000. Okay, and auto assign IP address. Okay, that's not necessary, but when you create a VC2 instance, you can enable associating a public IPv4 address to your EC2 instance. So at the end of the day, it is not physically attached, that IP address. That IP address is logically attached to your EC2 instance. But what is physically attached to your EC2 instance is the private IP address. Okay, and then natting happens between your private IP and public IP. And then finally, when the request goes out, it goes out as a public IP address. It does not go out as a private IP address. Okay, so now this is the concept of NAT, natting. Okay, so now what I'm going to do is I'm just going to clone this diagram, and I'm going to show you how it happens in VPC. You might be wondering how it's happening in VPC, right? I'll just remove this VPC network. Okay, this is my EC2 instance. This is my EC2 instance. I'll just change the IP addresses a bit. I don't want to use 10.1.0.58, 10.1.0.78. Okay. Okay. So now this is my 10.1.0.1. Okay, 10.1.0.1. I mean, if you recall, whenever you create a VPC and you assign a CIDR range, 5 IP addresses are taken away by AWS. What are those five IP addresses? Can somebody tell?
For maintenance.
Yeah, maintenance is fine, but what are those 5? Can you explain those 5?
VPC IP address and the subnet IP. Each subnet have individual IPs.
Not really. Each subnet will not have individual IP. Subnet is just a logical. VPC is also logical. Only EC2 instances will have IP addresses. Only resources have IP addresses. Your network in your home, your network itself doesn't have an IP address, right? Only when you connect your laptop or mobile, that gets an IP address, correct? So what are those 5 reserved IP addresses that VPC has?
First address 10.0.0.0 is for a network address, and 10.0.0.0.1 for VPC router, sir. And 10.0.0.0.2 is for DNS, sir. And 3 is for future user, and the last IP address is for broadcast, sir.
Broadcast. Excellent. Very good. So sorry, who was this?
A32, sir.
A32. Okay. Okay. Very good. Very good. Excellent, Prasanna. So these are the 5 IP addresses, right? So these are the 5 IP addresses that are reserved. Okay. So from that perspective, 10.1.0.1 belongs to the router's IP address. The every VPC will have a router. So it belongs to the router's IP address. So it will go there. Okay. So then there is also a EC2. If it is in a public subnet, then the EC2 instances will get a public IP address associated to it, right? So assume 45.87.56.75. Just going to I'll change this. This is VPC router IP address. This is VPC router IP address. This is the EC2's public IP. I'm just saying EC2 one EC2 second EC2 instance, right? I'm just saying this is EC2 one's public IP address. Similarly, you'll have a EC2 2's public IP address also. Okay. So now finally, when it goes out, the traffic will come to 10.10.1, which is the VPC's router, and you will have a router. This is your routing table. This is your route table, right? And within the route table, you will have route that says any traffic which is not known, which is 0000, then take it to IGW. Okay. So now which is IGW? This is IGW. Okay, IGW will be connected here. And it goes to IGW Internet Gateway, and then Internet Gateway will send it to the respective destination on the internet, which is mywebsite.com. When it goes to my website, it goes out as your EC2 one's public IP address. Okay. Whereas if you have another public IP address associated with EC2 second EC2 instance, let's say second EC2 instance has got a public IP address of say 76, just for the sake of theory, right? So this is the IP address of your second EC2 instance, right? EC2 2's public IP. So when the request originates from EC2 instance 2, it goes through this. It goes like this. Yeah, from here it goes like this. And then you will see that 45, 87, 56, 76 gets logged in the my website because it goes as the public IP of the EC2 instance. Okay. Again, don't compare this with your home network. I mean, I just gave an example here just to explain you the concept of NAT. But in home network, you will get only one IP address, okay, which is offered by the ISP. But AWS is not like that. Today, AWS owns the majority of the public IPv4 addresses. Okay, they have the maximum number of public IPv4. That's why they're able to allocate a public IP to each EC2 instance if you have it in the public subnet. Okay, and there is also a concept of elastic IPs where you can buy additional IPs from AWS and you can reserve it for your own future use. Okay, public IP addresses, because that is if you have public IP addresses, you will be able to connect to internet. Okay, so understand this concept very clearly, because what we are going to do now is we are going to do a small lab exercise where so now you have your VPC network, and this EC2 instances are in a public subnet. So that's why they are able to talk to the internet. But what if there are private subnets, right? If there are EC2 instances in private subnet and you want the EC2 instances in private subnet to talk to internet, then how will it talk? Okay, that is what we are going to do now. Okay, that is where NAT comes into picture and NAT comes handy. Okay, but try and understand this concept very clearly. Okay, I'll share this later. Just try and understand this. Okay, all right. So now I'm going to extend this diagram a bit. Okay. Okay, so I'll in fact use this diagram, public subnet diagram. Okay, I'll just use this diagram. In fact, what I'll do is, it's a good idea to actually add a new slide and say that what is the NAT. NAT is the topic that we're covering today, right? I'll just group. In fact, later on, what I'll do is I'll just group these whiteboarding sessions and then I'll give it to you so that you have a better. Yeah. Okay. So now, what I'm going to do is I'll just take this, just put it here. NAT VPC NAT. Okay, I'll just remove all of this. This is all not needed. This is not needed. This is not needed. This is not needed. And this is also not needed. The red box is also not needed. This red box is also not. Yeah, this is also obsolete. This is also obsolete. Okay. Okay. So now this is my public subnet and this is my private subnet, right? And you know the difference between a private subnet and public subnet. Can somebody tell me what is the difference between private and public subnet?
Public subnet has IGW, sir. The private doesn't. Subnet doesn't have.
Okay. Okay. So you're right. You're partially right. Okay. But you should not answer it this way. You know how you should answer when you're asked in interviews, what is the difference between public subnet and private subnet? You should say that the public subnet is the one which has got a route table associated with its subnet, where there is a route going from 00000 to IGW, so that the EC2 instances in the public subnet can have internet access and can be accessible from internet. Whereas private subnet is the one where there is no routable traffic to an internet gateway. So that's why they are private subnets.
Okay,
Should
sir.
be more descriptive and more elaborate as much as possible. Okay, because IGW is not attached to your subnet. Okay, IGW is attached to your VPC, not to your subnet. You don't create a IGW just for the sake of one subnet, but you create a route within the subnet that takes the traffic through IGW to public internet. Get it? That's how you should explain. Okay, so now I have a public subnet, and public subnet I have got a VPC EC2 instance 10.0.1.1.1.22, and which has got a public IP associated with it. So it works perfectly fine. This can talk to internet, and from internet you can also talk to this because you're doing SSH, correct? You're able to ping, you're able to SSH, provided you open the traffic in security group, you open the traffic in NACLs, you're able to do all of that, correct? So, but what about the private subnet? Poor guys, they don't have internet access. They can't have any fun on the internet, correct? So now let's take, for example, right? I've got an EC2 instance, which is 10.0.2.8, which is in the private subnet. In fact, we did create one. If you all remember, we created a private EC2 instance, 10.0.2.8. That's what I have here. Okay, we created it last time. I've just stopped it. Let me just start it. Let me fire it up. I'm starting it. So now this guy can't talk to the internet, and I can't even connect to it from the internet, correct? Because it doesn't have a public IP address associated with it. So this is where we did a lab exercise last time, where we first logged into the public EC2 instance through PuTTY, and from public EC2 instance, we copied the key using SCP. From that public EC2 instance, we connected to this private EC2 instance because these two are in the same network, correct? Okay,
Yes, sir.
perfect. So now, what if my private EC2 instance needs access to internet? Because I want to install some patches or I want to install some software on this. So how do I install software? Okay, that is where NAT comes into picture, and NAT comes very handy. Okay, what you do is you create an EC2 instance in your public subnet. I'm just going to move this to the right here. I need some space here. Okay, so you create an EC2 instance in the public subnet. Okay, this is an EC2 instance, which is, I'm calling it as a NAT instance. Okay, I'm just calling it as a NAT instance. And my NAT instance will have both private IP and public IP, right? Because I'm creating it in the public subnet. Okay, let's assume my private IP is 125 and my public IP is something else. Okay, I mean, I'll just giving some 167. Okay, that's my public IP and this is my private IP. So now my NAT instance can go to internet gateway because it has got a public IP to it. It can go to the internet gateway. Okay, and then it can talk to internet. Okay. So I'm creating this NAT instance, and then what I'm also doing is I'm creating a route between my, so this is subnet 2, this is subnet 1. In subnet 2's routing table, I'm actually creating a route in such a way that, okay, let's get the route table here as well for the sake of clarity. Yeah, so this is my route table, right? Now this is my public subnets route table has got 0000 pointing to internet gateway. So it's going to internet gateway, correct? Whereas in my private subnet, which is subnet 2, I don't have a route that goes to internet, which is the 00 route. I don't have because there is no because I don't want every instance in my private subnet to get access, internet access. I want only a few instances. Okay, let me add one more EC2 instance here in my private. I'll say that this is EC2 4. This is EC2 1, 2, 3, 4. Okay. Now I want my EC2 3 to have access to internet. I don't want my EC2 4. Now, how do I do it selectively? Because if you add a 000 route to my private route table, then this becomes a public subnet. Okay, because all my EC2 instances by default will have access to internet. Okay, and will not just access to internet. It will actually get a it'll actually get a public address space, right? So that anybody will be able to come from outside, hit my EC2 instance. I don't want that to happen. I want only a outbound connection. Okay, I want only an outbound connection going from my EC2 instance to internet, like how you guys do in your home, right? Where you connect your devices to your internet. Nobody will be able to come from outside and come to your laptop, but you can go from your laptop to and browse internet sites. Okay, that's because you have a NAT between your laptop and desktop through your router gateway, where there is a public interface. A hacker can come to this public interface and ping, but he will have nothing to ping. Maximum he can come till the router. Beyond router, he won't be able to come to your network. Your network is completely isolated. Okay, whereas you can go browse internet, but nobody from internet can come and directly hit your. But that is not the case with public subnet, right? In public subnet, when you have a EC2 instance which has got a public IP associated with it, you can browse internet from your EC2 instance. From the internet, anybody can come access your EC2 instance, provided they've got the key, provided they've got the authentication. Correct? That's what you have done, right? That is what you have done when you did SSH when using PuTTY, right? I mean, for example, here I'm using my PuTTY. I'm loading my public EC2 instance and I'm saying open. See, I'm able to connect to my EC2 instance because this is one of this. I'm on the internet here. Okay, this is not a private network. Okay, from where I'm connecting this PuTTY is not a private network. It is some other Windows machine which is lying in the internet. So I'm coming over internet and I'm able to access my EC2 instance. When you will not do that, but still, if your devices or if your EC2 instances need access to internet, like how you're doing it in your home network, right? Where if say there are 10 devices connected in your home network, not all 10 devices will have a unique public IP address, correct? They will all have only private IP addresses, but their IP addresses will get translated to the IP address of your router. your public interface of the router. That's why, when both laptop and desktop browsers mywebsite.com, mywebsite.com will receive the traffic only from 45, 87, 56, 75. That is the difference between natting your private IP address to public IP address through a common NAT device. It's called a NAT device. Okay. So now here in this case, what you have to do is your EC2 instances in your private subnet will not have a direct public IPv4 address. It will have only the private IPv4 address. So 2.8, and then you assume there's something else also, which is 2.9. Okay. Or let's ignore this for the time being. I've got one EC2 instance in my private subnet, which is 10.0.2.8, which is a private IP. But now I want internet access on this, only outbound internet access, not inbound. That is a difference. You should understand that very clearly. Only outbound, where only your EC2 instance will be able to talk to internet, whereas somebody coming from internet will not be able to reach this EC2 instance. Okay. So in such case, you need to add a route in the route table, in the private route table, which says 0000, which is I want my EC2 instance to be able to talk to internet, right? Which means it's any IP address or on the internet, which is 0000. I'll not take it through IGW, because the moment I put IGW as the target, then this will also become a public subnet, and this EC2 instance will start getting a public IP like this. Rather, what I will do is I will use the IP address of my NAT instance, which is 10.0.1.125. 10.0.1.125/32. Okay, we'll see that. We'll see how to do that. So that is what a NAT instance does, right? So where I'm just opening the documentation. NAT. I'm just going to NAT. I'm just going to NAT instances. Okay, what does it say? You can use a network address translation instance in a public subnet. So what have we done here? We have created a NAT instance in the public subnet in your VPC to enable instances in the private subnet to initiate outbound IPv4 traffic. Remember that very clearly. I'm again emphasizing that very clearly. Outbound, not inbound. From internet, nobody will be able to access this, right? You can use a NAT instance in a public subnet in your VPC to enable instances in the private subnet to initiate outbound traffic to internet or other AWS, but prevent the instances from receiving inbound traffic initiated by someone on the internet. I want all of you to learn this properly, okay, and mug this up. Okay, this is very, very important. Okay, but prevent the instances from receiving inbound. Okay, that is why you're using a NAT instance. If you provide, instead of this, if you give a IGW here, then your EC2 instances in private subnet, your private subnet, first of all, will become a public subnet. Then your EC2 instances will start getting a public IP address associated with it, which you don't want. So if you see this is the diagram. I'll just take this diagram and I'll just probably put it in a PPT so that it's more readable. Oops. Copy image. Yeah, pasted it here. Okay. I'll blow this up. Okay, so if you see, this is your VPC. This is your VPC. You have two subnets, subnet 1 and subnet 2. This is your public subnet. This is your private subnet. Okay, and your public subnet has got private IP addresses 10.0.0.5.6.7 because your public subnet's IP address range is 10.0.0.0/24. How many IP addresses /24 gives?
625.
256. 256, sir.
256, yeah, 256. See, it's a exponential number. It's a binary exponential number. Okay, remember that very clearly. Okay, all right. So this will have like 256 IP addresses. So now these are three web servers lying in my public subnet. They've got a private IP of 10.0.0.567. Similarly, they also have a public IP of 192.198.51.100. 198.51 is a public IP address range, right? They don't come under the RFC 1918 range, correct? Those three ranges that I explained. So they are public IP addresses. See, each instance has got a public IP associated with it. Similarly, I created a NAT instance, which also has a private IP address 10.0.0.8, and that also has a public IP address associated with it. And then it goes over internet gateway. Okay, there is a router in VPC or subnet that takes it to the internet gateway. So any EC2 instance which has got a public IP associated with it, which is there in public subnet, how will it be in the public subnet? Because in your route table you have 0000/0 pointing to internet gateway. So that's how it is getting a public IP address, and then it goes to internet, and it will be able to access internet. Okay, the top portion is clear. Now let's come to the bottom portion. In the bottom portion, I have a private subnet of 10.0.1/0.10/24. Okay, assume database servers are there, and I have three database servers: 10.0.15, 10.0.16, 10.0.17. Now remember, they don't have a public IP address. They don't have this green IP address here. Okay, because they're not in a public subnet. Why they are not in a public subnet? Because they don't have a route that says 000, which goes to internet gateway. But now you have created a NAT instance in the public subnet, which has got internet access. So now you want to do NATing of all your private IP addresses of 15.16.17 to this one single IP address, like how you do at home. In your home, you have one single router, and you have 20 devices connected to that router. And when all 20 devices access the internet, it finally goes out as this one single public IP address, right? So similarly here also, you've got this 3 devices, EC2 instances in a private subnet, and you have a route in the route table that says 0000, which is like on anything internet. Take it to the NAT instance ID. Take it here. Instead of taking it to internet gateway, you're taking it to NAT instance ID. So that way, eventually what happens is, when a request goes from 10.0.15 to NAT instance, it gets translated to 198.51.104, and then it goes to internet through internet gateway. But nobody will be able to come from outside. If anybody is trying to come to this 10.0.15, first of all, it is not routable from the internet, because 10.0.15 is not a public IP address, it's a private IP address. They can come till here, right? They can come to 198.51.104, but this won't allow a reverse traffic to come to 10.0.15, because there is no reverse traffic from NAT instance to go to this. So that's why it will be a one-way communication. It won't be a two-way communication. Understand that very clearly, like how it happens in your home internet. Okay, where it goes to internet, okay, and then nobody from internet will be able to initiate a new connection to your private IP address. If there is an existing connection which is already there, there is a TCP handshake that happened to one of the websites in internet, that will be able to communicate to you, because you already have a TCP handshake happen to that. So all that will go through this NAT instance only, because this is the gateway for your EC2 instance, the private EC2 instance. So let's do that. So I'm going to my EC2 instance. So this is my private EC2 instance, and this is my public EC2 instance. I'm just going to create one new EC2 instance, which says, I'll use Amazon Linux 2 AMI. I'll use t2.micro. You can also do that. You can also use t2.micro only. Don't use other things because of that. Okay, so now select the VPC. And here, most importantly, you have to select the public subnet. You have two subnets, right? Private and public subnet. Use the public subnet and auto assign public IP, because your NAT instance should have a public IP associated with it. Next, add storage, leave it default. Tags, I'll just give a tag as name, NAT instance. Configure security group. Okay, so in security group, what you have to do is you have to actually have, okay, so actually you can create a new security group. I'll create a new security group that says NAT instance SG for NAT instance. Okay, so your SG for NAT instance will have to basically allow all traffic. Okay, it has to allow all traffic, right? Because what's happening is your servers are going to talk to your NAT instance, right? It can be any traffic. It can be HTTP, it can be FTP, it can be TCP traffic, right? So you have to allow all traffic to that. Okay, and you can restrict the source. So in this case, the source that I want to restrict is, let me go back to my VPC. So here in this case, I want to restrict only to this range 10.0.20.24. Okay, I want only that source to be as 10.0.20.24/24. That is the source IP address that I want to give. So from that source IP address, from here, I want all traffic to go here. From here, it has to go to internet. Okay, that's why I'm restricting it in the security group, saying that allow, sorry, not all ICMP, I'll just say all traffic on all protocols on all ports. Okay, but allow it only from 10.0.20/24. Don't allow it from other subnets or any other locations. Okay, all traffic from subnet 2. Just say review and launch. Okay, 1 second. I'll just add one more rule for SSH, so that when we log into that. Okay, I've just also added an SSH. That's okay. For now, I've added an SSH, but you don't need SSH into that. Okay, so now, okay, I've selected an existing key pair that I have. I'll just go ahead and say launch instance. Okay, so let's go back and check whether the EC2 instance is provisioned or not. Okay, so my EC2 instance is provisioned, and if you see, it got a public IP address, and it has a private IP address also, which is 10.0.1.1.1.4. I'll update my diagram here. 1.1.1.4. That's my private IP address, and this is my public IP address. Okay. All right, so let it complete the checks. Okay, my NAT instance is still initializing, so let it complete the status checks. Let's just give it a minute or more. Once it completes the status checks, we also have to do something else to this. Right? Okay, I'll come to that shortly. See, I'm actually helping you set up one NAT instance from scratch. Okay, so that you understand the concepts. But there is an alternative for this, which is a service, which is a managed service provided by Amazon. you don't have to do all of this. Okay, I mean, this it can be made much simpler through the NAT gateways which are available. But I'm doing it because I want you all to understand, how NATing works and what are the steps involved with setting up NAT in case if you were to do it. Okay, so now NAT instance is up and running. Okay, so now what I also have to do is I have to go to actions. In the actions, sorry, in the networking, I have to go to select that NAT instance, select the networking actions, select the networking and say change source or destination checks. Okay. So, okay, what is the source or destination check, right? So now, usually what happens is in any network or any client server architecture, client is the source, server is the destination, correct? Client is the source and server is the destination. So one server, one device or one computer access the source, the other computer access the destination. It is either source or destination. It is not somewhere in the middle. It is not basically passing through something, correct? But here in this case, NAT is not like that, right? NAT instance is neither source nor destination. It is just a middle man sitting in the middle who's trying to give access to your. So in this case, what happens is it's just a middleman right here, right? Where you have source is this, destination is somewhere else. Whereas this NAT instance is just a middleman, right? So that's why you have to disable the source destination checks on that particular EC2 instance, NAT instance. And if you see here, there's a small information that it gives. If this is a NAT instance, you must stop source destination check. And NAT instance must be able to send and receive traffic when the source or destination is not itself. That is not the source or destination, right? Because the destination, it's only acting as a middleman. It's only a broker, right? I mean, if I need to say buy a house, right, I'll basically reach a broker. Broker himself is not buying or selling, right? He's only mediating between the buyer and seller. So it's like that. So that's why you have to go ahead and disable that. So you have to stop that. Just stop it. Okay. So source destination checks are disabled right now. Okay. Yeah. So source destination checks are disabled, and then you'll be able to use it as a NAT instance right now. Okay. So now what else do you need to do, right? Apart from this, there are a few more steps that you need to do. First step is, let's look at the documentation. Okay. I'm just going to go to this. Let me first log into my NAT instance. What is my public IP address of my NAT instance? 13.232.794, right? Okay, I will just put it to that. I'm putting it to that. Okay, how do I change this permanently? Okay, I'll put it to that. I'll just say EC2 user @ this. I'm going to save it as my NAT instance. I'm going to say it as NAT instance. I will just go to SSH. I'll go to auth. I'll select the key. The key that I have is, what is the key I gave? I think RPL lab, RPL Mumbai lab is the key I think I selected. That is the key that I have selected. That is the key I've selected here, and then I'll just save it. So saved. Okay, and then I'll say open. Yeah, since my security group is open, it is able to allow me to connect to that NAT instance. Okay, so now I've connected to my NAT instance, which is 114. Correct? It's 114. Correct? Yeah. See, it's 10.0.1.1.1.4. Okay. So now what we need to do is we actually need to go to this. Let me before that, let me actually take a sudo privilege. And then I'm just going to do yum update so that all latest updates are there in my NAT instance, and I'm not letting it go vulnerable. Okay, let's just give it a few minutes, couple of minutes for the updates to run. Okay, so that's because I've disabled the source. Okay, before I disable, I actually have to, okay. See, right now it is not allowing me to do that because I've disabled the source destination checks, right? So I'll just re-enable it and then I'll update it. I'll make the changes and we'll come back. Okay, I've re-enabled it. So let me just clear it. I'll again do a same update. I think it's trying to. Okay, so the yum is like taking, the other process is actually locking it. Okay, let's wait. Okay. Okay, just give me a second. Let me see what the issue is. I'll look out for this one. Oh, okay. One sec. We did some adventures with Knuckles yesterday. So let me see if I've reverted it back. Yeah, okay. This is the problem. You see, we did something with Knuckles yesterday, and your Knuckles are actually blocking it. Correct? I mean, it's only allowing port 22, right? So now I'm just going to remove. So that's the problem with Knuckles. Even though you don't have a security group, your Knuckles are creating a trouble, correct? So all traffic, all allow. Yeah. And then outbound, I'm just going to go bring it to my 100, all traffic, all allow. Yeah, so good. So that's fine. So now it should work. I was just wondering what is going wrong there. Okay, cool. So now, yes, now it should work. I'm just going to close this guy. We don't need this guy anymore. I'm going to go back to my EC2, other EC2 instance. Okay, this is the, let me just say sudo yum update. Yeah, see, it works. So now you got what the problem is. How do you troubleshoot, correct? It is actually NACL which was causing the trouble. Yesterday we had created those restricted rules in the NACL, right? So where the main gate security was not allowing the traffic to go in. It was only allowing for 422. That's why I was able to SSH, but I was not able to do other things. But if you need, internet access, and if you need more controls, NACL gets very difficult to manage. So that's where, usually in enterprises, what they do is they go for a firewall, a proper firewall. Okay, like a Cisco firewall or a Palo Alto firewall or a FortiGate firewall and things like that. Okay, got. So now update is complete. Update is complete here. So now let's go back and then let's do the source destination checks on the NAT instance. Go to instance actions, in networking, change source destination check and say stop and save. Yeah, it is done. I'll come back here. But before that, we just have to go ahead and etc sysctld, right? Yeah. etc sysctld.
Sairam Anna, sorry to bother you. Could you please check your
Yep.
Zoom chart for a second, Anna?
Okay, Zoom chat. Okay, sure, I can do that. Sure, I will do that. Okay. All right. Okay. So now what you need to do is, there is, okay, within Linux, you have something called IP tables. Okay, IP tables are nothing but it's a firewall at an operating system level. Okay. So now you have to go ahead and modify those firewalls and IP tables to in such a way that IPv4 forwarding is enabled, because what the operating system also does is it can either be a source or destination, right? It does not act as a pass-through. But in this case, we have to go ahead and change the NAT settings in the configurations to basically, okay, I'll just do a 00. Okay. Cat 99 Amazon.conf. So if you see here, this is where you guys have to go and modify it. So instead, Amazon's recommendation is all of this is available in the form of an AMI. Okay. So now what they are recommending is you don't have to do all of this. You just select an AMI which is already having these. That's their recommendation. So let's go ahead. Let's terminate this instance. I'm just going to terminate this instance. This is 114, right? Okay, I'm just going to terminate this instance. I don't need this instance. Rather, I'll create a new instance. I'll launch it from the NAT AMI. Okay, there is a NAT AMI which is there. Just go here to AMI and search for NAT. Okay, so if you go to the marketplace, okay, go to the community AMIs. Okay, you will find this NAT AMI, Amazon AMI VPC NAT, which uses an Amazon Linux AMI and which has all the NAT settings enabled in it. Okay, so you can use one of these AMIs. Okay, and I would suggest just make use of the latest one. It's anyways ordered by the latest. So just go and use this AMI. So that's what is being ref. See, Amazon provides Amazon Linux AMIs that are configured to run as NAT instances. These AMI include the string Amazon AMI VPC NAT in their names. Amazon, if you want, you can just search this. When you go there and when you search, just search with this. And you won't find it in Quick Start. You won't find it in My AMIs. Don't go to Marketplace. Go to Community AMIs. Okay, in the Community AMIs, select Amazon Linux. Right, and you will see these many AMIs available. So select this first AMI, which provides a Amazon Linux operating system, and then select this. And use t2.micro only. Select next, and put it in the subnet one so that it gets a public IP address. Add storage, add tags. Tags is name Nat Instance. Next security group. Use that same security group which we had created. Okay, which allows all traffic coming from 10.02.24, and it will allow SSH. Yeah, okay. So here you're getting an additional thing. Make general purpose SSD the default boot volume for all instances from the console going forward. Okay, well, let's see. Why did it ask this? If you go to the previous. Okay, here, by default the AMI has got magnetic. Okay, because to optimize on the cost, magnetic is cheaper than SSD, right? So, but you can leave it as magnetic, or it can be a GP2 as well. I mean, if it is, because there's no disk activity that's happening here, right? So you can just leave it as magnetic because there's not much of a disk activity that's going to happen. So that's why NAT instances have got magnetic. Continue with magnetic. Next. Yeah, that's okay. That's fine. I'm just going to say launch. I will use my RPL Mumbai lab and then launch it. Okay. So my second NAT instance is coming up. First one is terminated, so we don't care about that. Now let's look at this. Now this also has a public IP address or a private IP address 10.0.157. Okay, so now this is 10.0.157, not 114. 157, and my public IP address is this is my public IP address. Okay, and here it will be 10.0.157.32. Okay, so let the instance come up. Okay, instance is initializing, so let it initialize. So let's just give it a few more seconds for it to 2x2 checks to be passed. Once it is passed, so then we can actually go ahead and start making use of it. Let's see if it has come up. Okay, it's still coming up, but I think we can still connect to it. Let me just go ahead and connect to it. I'm going to my putty. I'll just go to my putty. I'll load my NAT instance. Of course, I'm using the same key because the IP address is different. My IP address has changed. I'll save this so that next time I use it to connect. Yeah, so I need to connect. Okay. Yeah, so if you see, I've connected to my NAT instance. I'll just do a sudo yum update. Yeah, let's let it download the updates and update the packages. Okay, it's running actually. Your NAT instance is running. Okay. So once that is done, then I also have to go and let it complete this. Then I'll go ahead and disable the source destination check so that it can act as a pass-through device, not either as a source or a destination. You have to remember these because this is a potential interview question. You may be asked when you create a setup a NAT instance, what is that additional check that you need to, what is the additional configuration that you need to do? You have to say that you have to disable the source destination checks on the networking. Okay, so now this is updated. So now let me go and change the actions of networking, change source destination check. I'll just say stop. I'll just say save. Yeah, that's done. And then let's quickly review the other setting which is there. Yeah, so this one /ect sysctlb, right? Yeah, cd/etc/sysctlb. Yeah, so you see, you get a NAT settings conf, right? So just say 10 cat and look at it. You will see that net IPv4 IP forward is set to true because it simply forwards the packets. Okay, it is not doing any. It's not acting as a source or a destination. Okay, so that's why you use this so that it automatically it runs at the startup and then it configures all the IP tables, masquerading and things like that. Okay, so now that is done. So now you have set up a NAT instance, and the NAT instance is up and running. It is sitting in the public subnet. It has a public IP address. Now let's go to the private subnet. Okay, so now subnet 2 is my private subnet. Okay, it does not have a IPv4 associated with it, or it does not have a route table associated which says 00, right? So this is my public subnet where my subnet is associated as 10.0.1.0.24 and routes are the local route plus the internet route which is going through internet gateway. I'll go to my private subnet. My private subnet has got the subnet 2, and the route has got got the local route. So now I'm going to edit this route. Say add a route. I'm going to forward all 000 to my private IP address, which is 10.0.157. Okay, I'm going to say 0000/0. Okay, I'm going to forward it to an instance, an EC2 instance. Okay, you can also send it to an EC2 instance, right? Instead of internet gateway, you're sending it to an EC2 instance. Remember this very clearly. Okay, and which EC2 instance you want to send it to? You want to send it to the NAT instance. Okay, so anything which is within the VPC, it will send it locally. But anything which is not a known IP address, which is the public internet IP address, it is going to send it to my EC2 instance, which is the NAT instance. I'm going to save the routes. Okay, I've saved the route. But before that, I'll just delete this. Okay, because I want to show you, how whether you're able to access the internet or not. Okay, so now what I'm going to do is I'm going to connect to my private EC2 instance, which is 10.0.2.28, right? How do I connect to that? I connect to that from my public EC2 instance. I'll keep this thing aside. I'll open another putty. Let me get this out of the way. Okay, I'm opening another putty. I'm opening public EC2 instance. I'll load it here. I'll say open. Okay, this is my public EC2 instance. I'm able to connect it from my internet. Okay, and I have got my key pair as well here. Okay, so now what I'll do is I will do SSH -i RPL Mumbai lab key.pem EC2 user @ what is the private IP address of my private EC2 instance? 10.0.2.8. 10.0.2.8. Okay, and remember we copied this key to this EC2 instance using WinSCP the other day. Okay, 10.0.2.8. What is the security group? Let me quickly check the security group of 10.0.2.8. Okay, yeah, so I have to change the security group of this. Add SSH. I'll just say 0.0.0.0.0. That's a security group is not allowing there. Okay. Okay, so I've gone here. So let me just kill this. And again, I'll try SSH. Just open the security group. I'll search for the security group. Yeah, so this is the security group. I'll just look at the inbound rules. SSH TCP port 22. Yeah, it's allowing outbound. Oh, there are no outbound rules. That's a problem, right? I need an outbound rule of all traffic. 200000. Yeah. So, see, we fiddled around with all of this yesterday, and today it's hurting us. Okay, so just come here, kill this, again go. It should be able to connect. See, it's connected. Okay, it's connected to my private EC2 instance, which is 10.0.2.8. What is 10.0.2.8 is my private EC2 instance. Yeah, see, 10.0.2.8 is my private EC2 instance, which is running in a private subnet. It does not have internet access. So that's why I had to take 2 hops. I first logged into my public EC2 instance within the network, and then from the public EC2 instance through the network, I've connected to my private EC2 instance. So now let me just do a curl, right? Google.com. It'll time out because it does not have internet access right now, because it's in a private subnet. Okay, let's wait for it to time out. It'll just say that it can't connect to google.com.
Excuse me, sir, but the security groups are stateful, right?
Yeah, security groups are stateful, but there is no route. Security group is just a gate. But there is no route going to internet in the route table, correct?
Just
Your
now you
security group
changed
can
it,
only.
this outbound rule, right?
Yeah, I changed the outbound rule.
Even
because
with
yesterday you remember when you no, so okay, so now okay, so the way it works is see the difference between inbound and outbound is it is stateful because when a client is actually trying to access my server, that's an inbound connection for my server, correct? In such cases, whatever port that the client is trying to access my server, those are remembered even for outbound. You don't need to explicitly specify an outbound. But here in this case, from this EC2 instance, I'm initiating an outbound, a new outbound connection, right? So inbound will not come into picture. This is a new outbound connection that I'm initiating. So in such cases, you need an outbound rule, correct? Because it is stateful, and it will first come, it will look at the outbound rule, because you are initiating. The server is initiating to a different server on the internet. So then it will come and it will look for rules and the outbound rules, and then it will say that, okay, there's nothing, but it won't allow any traffic to go out. That is the difference. So there is two ways that you have to look at it very clearly. See, inbound, outbound is not just in an isolated context, okay? Inbound, outbound is always in the context of two servers talking to each other. If I'm talking to you, it becomes inbound for you. If you are talking to me, it becomes outbound for you. It is not inbound for you.
Okay, sir, got it, sir.
Yeah. So now if you see, it is timing out because I don't have a route associated to go to internet. So now let me go to my VPC, right? I'll go to my route table. I'll look at my route table, which is my private route table. My private route table does not have a destination 0000. Now let me go add a route which says destination as 0000/0 to the NAT instance. I don't want to give internet gateway. I can also give an internet gateway, but I don't want to give an internet gateway, because the moment I give internet gateway, those will get public IP addresses, and then it will also allow inbound connections. I want to prevent inbound connections to my private EC2 instances. They are purely private. Right. Instead, so I'll just go select an instance. I'll select NAT instance. I'll say save routes. Now I'll go back. I'll just say curl google.com. Yeah, see, it works immediately. Okay, and I can do sudo yum update. It will be able to download the updates. It will be able to install the updates. Okay, so now that EC2, the private EC2 instance has got a internet connection, an outbound internet connection, but not an inbound, because it does not have a public IP address. So I'll go back to the console. If you go to the EC2 instance, so now this is a private EC2 instance, which does not have a public IPv4 address. It does not have a public IPv4 address. It only has a private IP address, but still it is able to access internet. It is very similar to your home network, right? So where in your home network, your laptop does not have a public IPv4 address, right? It only has a private, but still you're able to access internet websites. But if I try to intrude into your laptop, your router will block me. Okay, I can maximum come till your router, but beyond that, I won't be able to come to your laptop and steal your data. That is the same concept here. Okay, that's why it's very important that you guys understand the whole aspect of what NAT instances and how NAT instances work. Okay, so now what we have done is, let's complete this architecture diagram. Okay, I have a private EC2 instance in a private subnet. I created a new EC2 instance in the public subnet, which got a public IP associated to it, which is a NAT instance, and use the NAT AMI, which is available in the community marketplace, which are community AMIs, not the marketplace, the community AMIs, which will have the IPv4 forwarding rules enabled, and also all the IP tables masquerading is done accordingly. Otherwise, you have to do all of those manually. I would suggest you don't do that. I mean, if you want to learn, you can do that. There are so many articles to do that, but you can just leave it. And then what I did is I changed the source destination checks on this NAT instance to stop. Okay, so that it is neither a source nor a destination. It is just a pass through, because my source is this, destination is this. Okay, it's just a pass through. Then what I did, I went to my private route table. Okay, and then I added a new route, which is for internet 0000, and with the target as the instance of that instance ID of my NAT instance. We have to select instance there. Okay, so now this is how you go ahead and create a NAT instance. Okay, so now what are the disadvantages of this NAT instance? Because here I selected a T2.micro NAT instance, right? So now assume, there are 30 EC2 instances connecting to this one single instance. This guy can become a bottleneck. That is number one. Number two is, so because it becomes bottleneck, it might slow down the internet browsing on all the 30 EC2 instances, because it's a single point of failure, right? It is choking. It's like a small road, correct? I mean, if all of you have, I'm sure all of you would have gone to high-tech city from the high-tech city MMTS station, right? Now there's a flyover, so it becomes much easier to go from Kukatpalli or KPHB to high-tech city. You can take the flyover. But if you prefer not to take the flyover, if you take the road below the flyover and you go via the railway station, MMTS railway station, there is a very small tunnel. Okay, under it, there's a railway track going on the top. There's a small tunnel. Okay, only one car can pass through the tunnel. Okay, I still remember, several years back, like probably 10 years back or 12 years back, when we used to pass through that, the tunnel is a bottleneck, and only one car can pass through that. And in the mornings they used to allow one-way traffic. Okay, where traffic can go only from this side to high-tech city, and the evenings only from high-tech city to this side. They allow, the police used to allow that. So that way this becomes a bottleneck, so it can't take so much of traffic. That is number one. Number two is, this is again an EC2 instance. EC2 instances, the underlying hardware of EC2 instances can fail, right? And it's just a single point of failure. What if this NAT instance goes down for some whatever reason? It has an operating system issue, or it has the underlying hardware issue. So then you will lose internet connection on all your private subnets. Okay. And thirdly, you have to manage this NAT instance, right? So which is an additional overhead for you, correct? The company has to manage it, and they have to patch it. They have to, do all the maintenance activities on it. That is the third disadvantage. In order to circumvent all of this, right? So what Amazon AWS has done is, they have come up with a service called Nat Gateway. Okay. So I'm just going to show you how Nat Gateway looks like. So they've come up with a service called Nat Gateway. So the Nat Gateway is basically a managed service. So instead of this NAT instance, this is a NAT Gateway. I don't care about IP address and all of that. Okay. I just go provision a new NAT Gateway in my public subnet. Okay, which is, you can do it through the console itself. Okay. And then here in my private, and this NAT gateway is highly scalable. Okay, it's not like, it'll have a bottleneck, right? Because in this case, we provisioned a T2.micro. The T2.micro is a very small instance, right? It is like 1 CPU, 2 GB or 1 GB RAM, right? That is not good enough. That's very small for connecting, right? And they also, I don't want to keep upgrading that instance every time I add more devices to my private subnets, which needs internet access. So in such cases, what you do is, you create a NAT gateway. NAT gateway is a scalable, elastic gateway, NAT gateway instance. It's a managed service. You don't even have to worry about their private IP address, public IP address, or EC2 instance size, which AMI to use, source destination checks. You don't have to do any of those. You just go provision that NAT gateway, forget about it, and associate that NAT gateway here. Give that NAT gateway ID here. Like how you give internet gateway ID here, you give the NAT gateway ID here. Your EC2 instances will have access to internet through this NAT gateway. Okay, I'm going to provision that and show you how it looks like. Okay, I've got this NAT instance, so ignore that NAT instance for now. So for that, you have to go to VPC console and click on NAT gateways. So if you see this NAT gateway, go to the NAT gateway and create a NAT gateway. You guys don't do it because it's chargeable. It does not come under the free tier. Wait, let me check that, whether it comes under a free tier or not. AWS free tier. I don't think it comes under free tier. It's a paid thing. So no, NAT is not part of the free tier. So you guys don't provision it. If you provision it, you will get charged. And NAT gateway price is quite heavy. Okay, you don't do it in your accounts. Okay, again, I'm being very clear. Don't create NAT gateway in your accounts. That is the reason I'm showing it in my account so that you can replay this video. It's very simple. Okay, it's not a big rocket science. You can replay this video and then you can see the video and you can learn it, but don't provision this in your respective accounts because you will be charged. NAT gateway charges, I'll just tell you what is the NAT gateway charge. AWS NAT gateway pricing. Okay, it's like 0.045 per hour. It's like, yeah, 45 cents per hour. Of course, if you're willing to afford that, that's not a problem, but I'm just telling you, you'll just unnecessarily get charged on your credit card. 0.045 per hour, right? So if you just run it, say for 6 hours, you'll be charged probably 0.27 cents, which is into 75. You'll be charged some 20 rupees. Okay, I mean, I'm just leaving it to you guys. If you still want to try it out, but ensure that you deprovision that. Otherwise, you will be charged. It is 0.045 per hour, right? So if you run it for like say maybe 24 hours, one full day, you'll be charged $1, which is $1 is 81 rupees, 75 rupees. So you'll be charged 81 rupees if you keep the NAT gateway running for one full day. But if you want to run it for a few hours, which is fine. I mean, maybe you'll have to spend about 20-30 rupees. But again, as I said, it's not a big deal, right? It's quite simple, right? I mean, you just go to the console. There's so many videos for you to learn. You just need to learn it conceptually, right? If it's not that you have to. So just click on create NAT gateway and just give a name to the NAT gateway saying that my NAT gateway. Okay, I'm just giving a name. And then again, use the subnet, public subnet, because your NAT gateway has to sit in the public subnet, because that's where you have internet access, right? You don't have internet access in the private subnet. So put it in the public subnet, right? And then you also have to allocate an elastic IP to it, which is the public IP address, right? So just click on this allocate elastic IP. It will just automatically allocate one public IP, which is 3.7.238.6, right? And then you can just give a name as already there. Okay, very simple. You don't have to do anything. You don't have to create an EC2 instance, search for the NAT gateway AMI. And once the EC2 instance gets provisioned, connect SSH to the EC2 instance, manage the security groups, change the source destination checks, again, choose the right instance type. None of that is needed here. See, very simple. All that, whatever we did, right? All those elaborate steps, what we did is all simplified in one single window. Nothing else. You just need to give a name, select the subnet, and allocate an elastic IP, a public IP to that, and then say create NAT gateway. You're done. So it's just going ahead and creating the NAT gateway. Right? It'll take about 5 minutes to create the NAT gateway. So let's wait for the state to come back to active. So once it comes back to active, you can use this NAT gateway in as many EC2 instances as you want. Okay, there is no limitation. There's no kind of, if you want to give internet access to 200 EC2 instances, you can give internet access to 200 EC2 instances through this NAT gateway, where you just need to change the route. Okay, let it come back. I'll show you how to give a route to that. But before that, let me just go back to my private EC2 instance, and I'll say again, I'll say curl google.com. Yeah, it's able to access it, right? Now let me just go back to my route table before the NAT gateway gets provisioned. I'll go to my route table. I'll go to my private route table. I'll just go to my routes. I'm just going to delete this route. Okay, I don't want this route. Okay, which is going to the NAT instance. Okay, I've deleted that route. Now let me go back and I'll do the same, the curl google.com. Yeah, see, it won't work because the route is not there. Okay, so now let's wait for the NAT gateway to come back. So then what I'm going to do is I'm going to edit the route. I'm going to add a route to 0.0.0.0 to, if you see here, NAT Gateway. Okay, I'm going to associate this to that. But for that, let the it has already started showing up, but let's just wait for the NAT Gateway to get fully provisioned because it's still being provisioned. Okay, it'll take about some time. It'll take about 5 minutes for the NAT Gateway to get provisioned. Okay. In the meantime, let's look at some comparison of NAT instances and NAT Gateway. Right. Comparison of NAT instance and NAT Gateway. Number one, availability. NAT Gateway is highly available because it's a managed service. Amazon takes care of managing that service. You don't have to do it. And NAT gateways in each availability zone are implemented with redundancy. Create a NAT gateway in each availability zone to ensure zone independent architecture. But whereas in NAT instance, you have to use a script to manage the failover between instances, right? For example, if a NAT instance in this example, right? This is one availability zone. Similarly, you create one more availability zone and make that public subnet. Create another public subnet in another availability zone. Then you need to create the exact replica of this NAT instance, put it there. When this NAT instance goes down, you have to create a script to modify, all the routes to point from this to the other instance. That will be a manual activity. So that's what they are saying. Bandwidth, it can scale up to 45 Gbps. Okay, that is the internet bandwidth that a NAT gateway can have. It can go up to 45 Gbps. 45 Gbps is huge. Okay, my internet bandwidth at home, I have 150 Mbps. Okay, which is nothing compared to what 45 Gbps is, right? 45 Gbps is a huge bandwidth. Whereas if you go with a NAT instance, it depends on the instance type, right? Because if you have a small instance, it can only pass through so much of small data, like the high-tech city flyover that I gave. Sorry, the high-tech city tunnel that I gave you. But if you have a large instance, then the large instance can pass through so much of data. But again, that depends on, again, this price associated with that. Maintenance, it is managed by AWS. You don't need to perform any maintenance. Whereas a NAT instance, it is managed by you. You need to install software updates, patches, and everything. Performance software is optimized for handling the NAT traffic. Whereas in this case, it's a generic Amazon Linux AMI that's configured to perform the NAT, right? So it's not that optimized from a software layer perspective. Cost charged depending on the number of NAT gateways you use, duration of usage, and amount of data that you sent. Here, it is charged on the number of NAT instances that you use, duration of usage, and instance type. Here, it's a uniform offering from a type and size perspective. You don't need to decide, because when I created NAT gateway, I never gave what size I want, right? Small, medium, large. Public IP addresses, yeah, both get public IP addresses. Private IP addresses, again, NAT gateway also uses a private IP address from the address range, but it's not transparent to you. You don't have to worry about it. So security group, you don't have to manage the security group in NAT gateway because you can't associate a security group with the NAT gateway. You only need to associate a security group with the instance public, the private EC2 instances. And there are so many other things that are there, right? So yeah. So these are all the differences between comparison between NAT instance and NAT gateway, but it's always preferred to use. I mean, if you have a small setup and if you think you can still run the show with a NAT instance, go ahead. I mean, that's not a problem, right? So for the sake of today's lab exercise, you guys can create a NAT instance and try it out, but don't create a NAT gateway. Okay. I mean, if you still want to do it, but ensure that you deprovision it within 2 to 3 hours of time so that your cost can be minimal and it'll unnecessarily charge your credit card. Okay, so now my NAT gateway is created. This is my public IP address that I have to my NAT, and this is my private IP address that I have to my NAT. Okay, so now I'm going to go to my route table. I'm going to my private route table. Okay, and what I saw here was my Google failed here, right? I was not able to connect to the Google. So now let me just go to my private route table. I'll edit my routes. I'll say 0000. Instead of selecting a NAT instance or internet gateway, I'm going to select a NAT gateway. I'm going to select this NAT gateway and then save the routes. Because now all my 00 is going through this NAT gateway. So I'll just go back to my putty. I'll say curl google.com. Yeah, see, it works because it has internet access now, and it's going through the NAT gateway. Okay, so that's kind of a good benefit that you have with NAT gateway, right? And you ensure that you don't really manage the underlying EC2 instance for NAT instance. Okay, so yeah, I mean, we wanted to cover VPC DNS also today. No problem, we'll cover DNS and DHCP option sets tomorrow. Okay, we'll cover that tomorrow, and probably we'll have a small quiz tomorrow. Okay, because DNS and DHCP option sets are two small topics. So what I'm going to do tomorrow is, I'm going to just cover this DNS DHCP option sets in first half an hour or 45 minutes, and then I'm going to conduct a gamified quiz for all of you. Okay, it's a very short one, but it'll be fun. Okay, it'll be a good learning opportunity. Let's do that tomorrow. But for today, assignment. Learn about NAT instances, NAT gateways. I've given the link. If you go to this NAT under VPC documentation, so you should bookmark all of this. Okay, go to the VPC main page documentation, bookmark this, and every time just go open the bookmark, and then you can browse through the topics that you want. Today you learned about NAT gateways and NAT, right? You can just go to NAT, start learning about NAT. Okay, start going through this, and then you can just go to NAT gateways, NAT instances. So we did NAT instances today, right? Okay, so now let me just jot down the assignment for you. Create a provision a EC2 instance in the public subnet. Okay, what is a public subnet? Yeah, in the public subnet one. The public subnet one. Okay, what are the steps to that? That is the first one. But what are the sub steps to that? The first step is launch EC2 instance wizard. Okay, select search for NAT Amazon VPC NAT in the AMI step and select the first step is choose Mumbai region. Okay, and select the first AMI. Okay, and then in the instance settings page step, choose the my VPC subnet one, which is the public subnet. Okay, and then click on next till security group screen, create a new security group with the following rules. I'm just going to paste that rules here. That is inbound. And then outbound is okay. And whatever you have done yesterday, right? I mean, based on the knackle exercise, you have to clean up all that. Okay. Otherwise, you will face issues like what I have faced today. You have to ensure that you clean up all of that. Okay, this is inbound and this is outbound. We launch the instance. Okay. Once the NAT instance is launched, choose the instance in actions, network, actions, networking, change source destination check, networking, change source destination checks, and stop. Click on and check the stop checkbox and save. Okay, that is the next step that you need to do. Okay, now you have done that. So then go to the route table. Go to the VPC console. Select the route table of private EC2 instance of private subnet. Okay, private subnet 2. Select this. Go to routes. Click on routes and add the following route. Oh, sorry, it has to be NAT instance, no? Yeah. Add the following route 0000/0 is the destination. Target is, you have to select that instance. Select the NAT instance. Select instance and then select the NAT instance EC2 from the list and then save. Okay, so once you save it, you will get this. Yeah, that's it. And then log in to the public EC2 instance. SSH to the public EC2 instance. From the public EC2 instance, SSH to the private EC2 instance. Then run the command curl google.com. You should be able to get a response immediately. Okay, I think we captured all the steps. Okay, assignment is hands-on with NAT instances. Okay, once complete, terminate the NAT instance and clean up all the other EC2 instances and security groups. Or if you want to stop, you can stop it, but ensure that you don't cross the storage, right? If say I have like 3 EC2 instances provisioned, right? Each EC2 instance has got a 8 GB storage associated with it. So 3 8s are 24. But I'm not exceeding my 30 GB limit. Okay. Each EC2 instance has got a 8 GB is EBS volume associated with it. So I'm not exceeding it. Okay. So that's kind of, and then you can also stop it if you want. You can stop it. Okay. But I'm going to just go ahead and clean it up. I don't need this. I'll just actions. Sorry, instance state, terminate instance, terminate. And I'm going to go to my private EC2 instance and stop it. Stop it because we will use it for other exercises. And I'm going to go to public EC2 instance and stop it. Stopped it. Let it all get stopped. And for these 2 instances that I'm running, I'm only using 16 GB of underlying EBS volume, which is free. And then I'm also going to go to my NAT Gateway and kill my NAT Gateway. I don't need it anymore. Okay, I'm just going to come here, select it, delete NAT Gateway. Just say delete. It's asking for a confirmation. Just say delete and click on delete. Yeah, it's deleting. And then I'm going to go to my security groups. I had this NAT instance security group, right? I'll just delete it. Security groups are not charged, okay? Just delete it anytime. I just deleted it. All I'm left with is only one public SSH access all. That's it. That's the only one that I have. Okay, I've cleaned up all my resources. It's always good to do a cleanup. Yeah, so everything is stopped. Yeah, I can now stay peacefully without the fear of getting charged to my credit card. Okay. Cool. All right. Any questions? Any doubts? I'm going to give you all this material. Just share it on the chat. Okay, everyone in the meeting, I'm just giving you both the files. Assignment for today, 29th October, and the PPT, whiteboarding PPT. It's quite interesting, isn't it?
Yes, sir.
Yeah. Yeah, because, see, these are certain things that, I mean, because of cloud, you're able to learn. See, these are all networking concepts, okay? I mean, you have to basically go and understand, people go for a very elaborate trainings on networking, like CCNA and all that, right? So there also, if you see, they teach about routing, security groups and all of that, right? But here, because of cloud, you can test it out. You can test all of that. Now you know how your home router works, correct? Because of how your network address translation works in your home router, right? I'm sure some of you would have made an attempt to understand how it works in the past out of your curiosity, but now conceptually how it works, how the NATing works in your home router, right? And how it basically behaves, right? And how when 20 devices are connected, how those 20 devices are going as one single public IP at the end of the day. Okay, that's why when you do what is my IP, you're actually doing that from your laptop, right? Which is your private IP address. But eventually, when the response goes to that what is my IP Google, and then when Google response returns that response, Google is returning it because Google is seeing the request coming as your public IP, not as a private IP. That's why you're able to see that what is my IP. You can try that at home, right? If you have got, if you have your mobile connected to it and laptop connected to it, run what is my IP from both mobile and laptop. Both will return you the same public IP. Okay, so do this. I mean, complete this assignment for today. And tomorrow we are going to look at two topics. One is DNS and the other one is DHCP option sets. They're not so complicated. I can explain you. I mean, even if you don't understand it to the nth level, that's okay. That's not a problem. But you just need to understand at a conceptual level what is DNS is, what is DHCP is. So once that is done, we will take a logical pause with VPC. Okay, and then we'll go back to EC2 instances. And in EC2 instances, what we will start from next week is I'm going to start, how do you add more volumes to your EC2 instance, EBS volumes to the EC2 instance. Then I'm also going to show you how to use a script in a EC2 instance with which you'll be able to automate certain things in a EC2 instance. Okay, and then I'm also going to show you how to use auto scaling in EC2 instances, right? So when you have a website, when you build a website, and when users are hitting the website, and then when suddenly the number of users have increased due to whatever reason, right? And then in such cases, like Amazon had a Dasara sale, correct? Big billion day sale and things like that, right? So now in such cases, more people will be using Amazon's services, right? Such cases, it has to automatically scale up and scale down, or scale out and scale in, right? So we are going to see that auto scaling next week. Before auto scaling, I'll show you load balancing. What is load balancer, right? Because load balancing is very, very important concept, right? So where you have, say, 5 web servers, right? Each web server is serving website. So now you want to distribute the load across these 5, because based on that, because only one server can't take so much of load, correct? Even if you put a large server, it can't take so much of load. And that's not the best practice also. You can't make one guy take so much of load, correct? The load has to be equally distributed, right? If there is a function happening at home, there'll be so many people, right? Your brothers, sisters, family members, friends, everybody will come together and each one will take one responsibility to get the function successful, right? That way, here also, there has to be a load balance that needs to happen, right? So where somebody tells that, okay, you do this work, you do that work, you do this work, right? And so that way, load balancer is the one where it basically sits in front of all your web servers, application servers, and then it balances the load, where it sends one request to one node, the second request to the second node, third request to the third node, right? How many of you know algorithms? How many of you have learned algorithms in the college? You actually had one subject called algorithms. What, can somebody tell me one algorithm which you have learned?
I know a few algorithms in regarding data mining subject.
Okay, excellent. Can you tell one algorithm? Name that algorithm.
Linear search, binary search.
Okay, very good. Linear search, binary search.
Bubble
Right? So
chart.
similarly, right. So similarly, in load balancing, there is an algorithm called round robin. How many of you know round robin? Read about round robin over the weekend. Okay, round robin algorithm, right? So where it just, say there are 10 targets, round robin keeps going one after the other. First request goes to the first one, next request goes to the second one, third request goes to the third one, fourth goes to the fourth, like that. Again, the first, then the fifth request comes to the first, sixth goes to second, seventh goes to third, eighth goes to fourth. So like that, it's a round robin algorithm, right? So there are many algorithms like that. So we will learn about that in the next week. Next week is all going to be on EC2. Okay, it's going to be completely on EC2 next week. Okay, we are going to look at all the other features of EC2, right? And how auto scaling works, how load balancing works in EC2, right? Once next week is done, week after next week, we will start learning databases like RDS, other managed services. Okay, so where you have RDS is a fully managed database, right? So I'll show you how RDS works. Okay, and also, and then 1 week, we can spend on serverless architecture. Okay, serverless is the crux of the whole cloud. Okay, you have to learn the serverless architecture, serverless components, so where you don't need to manage any EC2 instances, you don't need to manage any security groups, nothing. In a serverless architecture, you just go configure everything from the console. You can get your website up and running in a very short time. Okay, and I'm also going to cover S3. S3 is a object storage. S3 is a very, very important topic. Okay, we'll cover it week after next week. Okay, I'm going to cover S3. S3 is a very important object storage that AWS has. Okay, so S3 is going to be a pakka interview question. Okay, if you go and attend interviews, you'll be asked about what an S3 is, how S3 works, right? And then I'm also going to cover about IAM. Okay, identity and access management. That's a very, very important topic. Okay, IAM is the core of entire AWS, where any access is managed using IAM. Okay, I'm going to cover IAM. I'm going to cover S3. I'm going to cover more of EC2. I'm going to cover more of serverless components, serverless architecture like Lambda functions, DynamoDB, API gateway, right? These are some things that I'm going to cover. And apart from that, middle, we'll take we'll take about 2 to 3 days out to cover the cloud formation, and I will also show you Python scripting for AWS. That was one topic that is still pending. I'm going to show you how you can run Python script so that you can completely automate things, right? You don't have to rely on console, the web console that you have. You don't have to rely on the console. You can log into your laptop and you can open a terminal, or you can open your power command. If you're using Windows, you can use PowerShell. Using PowerShell, you can actually manage, you can start EC2 instance, you can stop EC2 instance, you can create EC2 instances using a command prompt. Okay, and then we can write shell scripts using those. Shell scripting, we learned shell scripting in the week 1, right? Or week 2, sorry. In week 2, we learned about shell scripting, right? So now you can use shell scripts to create EC2 instances, to manage EC2 instances.
I know a few basics of evolutionary algorithms also, sir.
Okay, cool. That's great.
Okay.
Excellent. Okay, and we're going to cover all of this over the next 4 weeks, 3 to 4 weeks. We're going to cover all of this, and maybe by the end of the next 4 weeks, you'll have a very decent understanding of AWS, and you'll be able to confidently attend interviews, right? And then you can start learning more and more, right? And then I'll point you to a lot more material. I'll point you to a lot more videos, and I'll give you, in fact, what I'll do is I'll start filling up one document where there's so much of content available on the internet, like basic videos and basic learning material. Okay, on all these topics, whatever I've taught you till now, I'll start filling that. I'm going to give you that book of knowledge. Okay, I'm going to give you that bank of knowledge to you, so that you can even after the courses, after this course is over, you can refer to that along with the other material that I've given you. You can start learning, you can start practicing, you can start writing your own, building your own examples and things like that. And then I'm sure once you guys face interviews, you'll sound a lot more confident, and you'll be able to get decently placed in somewhere as a AWS developer, as an AWS administrator, as an AWS engineer, cloud engineer. Okay, but so far I'm hoping all of you are enjoying the sessions, right? And so a lot of learning, right? A lot of learning curve, right? I understand. I mean, this is not easy, right? It takes some amount of hard work, and it takes some amount of focus to kind of learn these topics. You're not going to get it up and running in probably about a month's time. It will take some time, but at least you're getting introduced to all of this. That itself is a good thing, right? And you guys have to make use of this opportunity and start learning and make an attempt from your perspective to go additional miles to enhance your knowledge, because what you're doing currently is just scratching the surface. AWS platform is huge. I mean, trust me. Okay, I'm working at AWS and I keep coming across a lot of things on a daily basis. Okay, and there's so much to learn and there's so much to experiment. There's so much to kind of get your hands dirty with. Okay, I'm still struggling. Okay, I'm still basically learning on a daily basis on few advanced topics. Okay, on serverless architectures, microservices, on containers. I'm going to introduce you to all of those. Okay, but again, on containers and Dockers, I'll give you a 101 or a 102 kind of level, because those are very, very involved topics. But I'll point you to a lot of good material which you can read. But I'm going to introduce you to all of these concepts so that you understand, and holistically you understand, okay, what is what and what to use where, and how do you use that and how do you implement it, right? So that when you face interviews, you'll be able to confidently answer these questions properly. And after that, once you get into a job and once you get on the job experience, that is going to further add as a catalyst to enhance your knowledge. Okay, that's how you learn. You first learn the concepts, you learn how it works, then on the job you apply that. The job is going to give you more experience on several scenarios, several architectures, several design patterns. So that way you keep enhancing your knowledge month after month, year after year, and that will lay a very strong foundation for your career. Okay, all right. I think we should just take a pause here today. I mean, it's kind of, I understand it went on for 2.5 hours almost, but yeah, let's take a pause here. Just do the exercises that I've given you, assignments that I've given you, and we'll go as per our plan. And then, we'll meet tomorrow. And I'm going to spend some time for DNS and DHCP tomorrow. After that, I'm going to conduct a quiz on all the topics that I've taught you. Don't worry, it's not going to be a very tough thing, but it's going to be a fun. Okay, and there's going to be a leaderboard, and there's going to be it'll be a different experience, a fun experience.
Excuse me, sir.
Yeah.
Sir, can you explain how to connect with public EC2 instance and private EC2 instance in Linux, sir, by copying files and all by using scp command?
Okay, you want to do it in Linux, correct?
Yes, sir.
Okay, I'll show you. Which Linux are you using? Ubuntu?
Yes, sir. Ubuntu.
You're using Ubuntu, right? Okay,
Yes,
I'll
sir.
share my screen.
Okay.
I'll quickly walk you through. Okay, is my screen visible?
Yes, sir.
Okay, but before that, let me just go and fire up my instances back, both my public and private. I just stopped it. I'll start it. Okay, so let it come up. Okay. Yeah, okay, let it come up. I think it has come up. So this is my public IPv4 address of my public EC2 instance, right? So you said you're using Ubuntu, correct? You go to your terminal of Ubuntu. It looks something like this. Okay.
Yes.
Once you are in the terminal, but before that, just check the security group. Whether am I allowing SSH or not? Yes, I'm allowing SSH on 0000. So I'll be able to access it from public internet. Okay. So, and also look at what is the key that you're using. The key that you're using here is the RPL Mumbai lab. That is a key that I'm using, key pair that I'm using. Okay. So let me just go to that place where I have my keys. I'm just going to go users. Okay, this is the place where I have all my keys. Okay, where is that key? RPL Mumbai Lab. So I have the key here. I have the PEM file. So this is the PEM file that you would have downloaded when you created the key. Okay,
Yes.
I have the key there. So now let me just go. I'll copy the public IPv4 address of it. I'll come back here, go to the terminal. You cd change directory to the place where you have the keys.
Yes, sir.
Okay, I'll just say ls-l RPL, right? RPL Mumbai. Yeah, so this has restricted access, correct? It has to be chmod 400. Just ensure that it has. Then what you do is type SSH. The SSH will be there in any Linux. Okay, that's a command which will be there in any Linux.
Okay.
SSH -i rpl-mumbai lab.pem file, and then say ec2-user @ give the public IP address. Give the public IP address. This is the command. Just make a note of it.
Okay.
SSH-i rpl Mumbai lab. Then once you are in, it's going to ask you yes, then connect. Okay.
Yes.
So now you also have to connect to the private instance, right? From this.
Yes. Yes, sir.
So now you need the same key present in your public EC2 instance, which is 10.0.1.122. You need the key present here, right? Because you need to follow the same step to connect to the private EC2 instance also.
Yes.
Okay. So for that, what you can do is you can, okay, now I'm just exiting this. I'll just exit this. You can just do a cat RPL Mumbai lab PEM. Just copy this. Copy this to the clipboard.
Okay.
Copy only this portion. Start with begin RSA to end RSA, and then go to the edit and then just say copy.
Okay, sir.
Okay. So then do an SSH. Then clear the screen. Just do an SSH to the public EC2 instance. You have gone to the public EC2 instance. So here, just do a VI. You'll be in the home directory. It's just /home/EC2 user. So then say VI rpl-mumbai lab. I think I already have. I'll just say new.pem. You're creating a new file, PEM file.
Okay.
Okay. And then do this and then go into edit mode and then say click on edit and say paste. Okay. You would have pasted the private key to this. Okay. Then come out, save the file. Okay. Now you have saved the file. So ls-l rpl Mumbai lab new.pem. Okay, but this is wide open, right? You need to change the permissions. chmod 400. So then you have permissions are limited. So now you will be able to connect to your private EC2 instance using this key. Using this private key, EC2 user. EC2-user @ go to your private EC2 instance. What is your private IP address of your private EC2 instance? 10.0. You are connected.
Yes, sir. Thank you, sir.
Okay.
Yes, sir. Thank you.
Sir, sir, I observed one thing. When you are working with the EC2 instances, your instance is always up, sir, even when you delete allow all traffic from NACL, but still that is up. But for me, that is not working, sir. When I delete that rule, my SSH immediately becomes inactive and it shows an error like software connection abort.
Yeah, that's because when you change the NACL or security group, as I said, it's real time. The changes will happen real time. So you need to allow
and then you have to again reconnect. Even in my case, it'll abort only. It won't. So you want me to show that? I can show that to you. So right now I'm connected to this, right? Say I'm connected to the public EC2 instance, right? This is my public EC2 instance.
Yes, sir.
10.0.1.22. Okay. So now I'll go and change my NACL. What do you want me to change? You want me to change the NACL or security group?
NACL, sir.
You want me to change the NACL, right? Okay. I'll just go change my NACL. This is the NACL associated. Okay. With both my subnets, right? I'm just going to say edit inbound. I'll just delete this. I'll just say I'm denying all traffic. Okay. I'll just go edit outbound rules. I'll deny all traffic. Just saved. So both inbound and outbound are denied. See, I can't access. I'm pressing enter. After some time, it will say connection timed out, and then it will exit. It will come back to my Mac terminal.
Okay, sir.
If it were putty, in putty also it would have just terminated. You want me to show that? I can see connection broken pipe.
Yes, sir.
And
Sir,
if you
if
see,
I give my IP,
even in putty, if it has terminated that. It is all real time. Yeah.
okay, sir. Sir, if I give my IP, then
Hmm.
also even I could not able to connect to my instances.
No, so that see
What
NACL.
is the reason?
Usually NACLs. That's what I'm saying. In NACLs, you have to ensure that you whitelist everything in both inbound and outbound. As long as you do that and allow that, and you allow that in security group, 100% it will
Outbound
work.
also.
You're just doing some mistake somewhere. In NACL, you have to do it in both inbound and outbound, and in security group also, you have to allow that in inbound and keep outbound as 00, the default rule.
Oh, okay, sir. Okay.
I'll just go down allow all traffic. Here also I'll just add a rule, otherwise we won't be able to continue with the rest of the lab exercises. All traffic allow. So now it will work. Now if I again try to connect, yeah, it works. See, it's immediate. It's almost instantaneous. Okay, and if you go to my security group, in security group I have got, not the default one, public SSH. I have my inbound as 00. TCP22, which is SSH, and outbound I have all 000. So keep it always. This is not a problem. Your outbound, you should be able to talk. If you restrict your outbound, then you will have such issues.
Okay, sir.
Okay.
Okay, sir. Thanks a lot, sir.
Okay. All right. So I think let's connect tomorrow. So now all of you can go into your breakout rooms and
Hello.
complete the exercises that I've given you.
Hello, sir.
Okay,
Yeah.
sir.
Sorry, sir. Sorry for the interrupt. Sir,
No problem.
you are already discussed about the cloud engineering and the AWS engineering, all the roles present for the total AWS course. We are already learned about Linux and databases, and now AWS here. So for all these course, what type of roles are present? Please discuss about also, sir, for this. Give
Sure.
this information.
Sure, definitely. I'll talk about it. I'll, in fact, dedicate one day, just to talk about these roles and what sort of job opportunities that you will have for all of these roles. Plus, whatever that you have learned in the past, plus what you're learning now, what sort of opportunities you can expect, and what you should learn more. Okay, I'm going to spend one day dedicated on this
Yes,
sometime.
sir. Okay. Thank you, sir.
Okay. All right. But the
Okay.
only thing that I want all of you to follow religiously is please join the class at 9 o'clock or before 9 o'clock, 8:58.
Okay.
Okay. I see today also, I see that, slowly people are coming like 9:15, 9:20, 9:30, right? And today, if you see, okay, of course, 82 participants. It was 89 sometime back, but I don't know. 6, 7 people dropped off.
Okay, sir.
Okay, see,
Thank you.
we are kind of spending time for all of you, right? I mean, so you also have to reciprocate it from all your side, right? And ensure that you join the classes on time. See,
Yes.
this is a great learning opportunity. Okay, this is an
Yes.
excellent learning opportunity. So you all have to be, on time, be punctual, and don't drop out in the middle. Okay, which does not, which is not going to serve any purpose for you, right? I mean, if you just drop off and see right now, I just helped you troubleshoot two key issues, right? I mean, that's the way
Yes.
you learn things. The more and more you troubleshoot, the more and more you see such scenarios, you will learn a lot. Okay, so
Yes.
start before like 9 o'clock and stay till the end, and after that go into your breakout rooms and start looking into your exercises. Come back tomorrow if you have any questions. Again, you can ask me tomorrow in the session the questions, and I'm happy to help you guys. I mean, this applies to everybody. Okay, so please be on time and please attend the classes. Don't skip any class. Please block like 9 to 12 or 8:30 to 12. Just block. Don't give room to any other things, come what may. Okay, that is the conviction and that is the determination that all of you should have. Okay, in fact, I have done that. Okay, I've got a lot of other appointments which I cancelled. Okay, for the next 2 months, for these 2 months, I've just cancelled everything. October, November, till mid December, I've cancelled everything. Okay,
Yes.
in fact, if you see my calendar, I have actually blocked my calendar from morning 9 to 11:30, and no one can take away my calendar, and nobody can schedule any meetings or nothing. I'm just dedicating it only for this sake, right? So I mean, so please be quite conscious about that, and let's all. I mean, there's a great learning opportunity for all of us, right? So let's be quite serious about it.
Yes. Okay, sir.
Okay.
Okay, sir. Thank you.
Right. Yeah. Sure. Thank you. Thanks all, and have a good day. So Sai Krishna, over to you. Please allow them in the meeting room, breakout rooms, and
Sure, Anna. Thank you so much, Anna.
thank you so much.
Shailo Anna, you wanna open the breakout rooms?
Thank you all. Bye. Have a good day. Sai Ram.
Bye, Anna. Thank you, Sai.
Bye. Bye.